I hope all of you are doing well. My name is Riya and let's quickly get started on the first video for memory management. So whenever we do talk about memory management, right, before that, we will talk a little bit about what exactly memory is. Okay. So memory can be defined as a collection of data in a specific format. Okay. So data is basically put together as a collection, but all of it is in a specific format. And as well as it is used to store instructions and some data which has been processed. Okay. So computer memory can actually be defined as a collection of data represented in the binary format. So here that format is usually the binary format. Okay. A computer device, right, is basically a computer device that is capable of storing any information or data temporarily or permanently is called as a storage device. Correct? So that is what the overall idea is, right? Whenever you have some data, you always store all that data in your computer system, in your storage devices in the binary format, because computers only understand zeros and ones, right? So that is why anything that you store in your computer is always, or in your memory, is always in the binary format. Okay. Then the idea is, what is memory management then? So in multi-programming computers, the operating system basically resides in a part of memory, okay, and the rest is used by multiple processes, okay. The task of subdividing the memory among different processes, right, is called as memory management. Now, if there are a lot of processes, all of them would require memory, correct? Now, this task of having this big chunk of memory and dividing it into smaller tasks, okay, or smaller parts, right, so that every process can get some part of the memory, is known as memory management. Okay. So memory management is basically a method in the operating system. So it's a functionality, it's a management task for operating system to basically manage the operations between main memory and disk during process execution. Okay. So like I told you, there is a lot of to and fro of how programs and processes move from the secondary memory to the primary memory, or also known as the main memory. Okay. So operating system is basically a way, right, or memory or operating system basically tackles these operations of managing the processes which are moving between the main memory to the disk. Okay. And the main aim of memory management is always to achieve effective utilization of memory, right? The idea is, why are we really doing memory management, right? If there are a lot of processes, why not just go and do the allocation among different processes? Why is the need, right? Why is the need to do such kind of like a bifurcation in a optimized format? Because memory is less and processes are very high. So we want to make sure that there is efficient utilization of memory. No part of memory is getting wasted. And memory management as a phenomena helps to take care of this thing. Okay. In a multi-programming system, right, the user part of the memory, okay, may be further divided to accommodate multiple processes. So further you will see is that in the memory you store the operating system, you store the user processes also, right? So that in the user part of the memory, it can be further divided to accommodate multiple processes. Okay. And this task of the subdivision, right, of the memory is carried out dynamically by the operating system. What do you mean dynamically? Dynamically means that as and when the request comes, as and when more processes come in the system, we keep on doing the task of subdivision of the memory, and this kind of a process is known as memory management. Okay, that's what memory management actually is. So over here, next what we will talk about now is the concept of logical versus physical address space. Okay. So what happens is, an address is basically generated by the CPU, and it is usually and commonly known as logical address, okay, or also known as virtual address. Whereas the address which the main memory understands, or which is seen by the main memory, is known as physical address. Okay. So the logical address is basically the address of all the instructions or the data basically used by a program. Okay, so here you can see, let me write it down in fact so that you can have a better understanding over here. So we are talking about the concept of logical and physical address space. Okay, so whenever we talk about logical address, okay, logical address is basically the address of an instruction or the data used by any program. Okay, so what we say along with that is that the set of all the logical addresses, okay, so a program will not just have one instruction, right? It can have multiple instruction. So the set of all the logical addresses which are generated by a program, okay, is known as logical address space. Okay, where we basically have the address of all the instructions related to a program. Okay, now logical and physical addresses are basically the same only when it is the compile time. Okay, and the are same in compile time and load time address binding schemes. Okay, and logical and physical addresses differ in execution time address binding schemes. Okay, we'll come to that also. Now, what happens is the address that is actually loaded into the memory address register of the memory is known as physical address. Okay, and the physical address cannot be accessed by the user directly. Okay, but the user can calculate the physical address with the help of a logical address. Okay, let me write this down as well so that you have something to remember over here in terms of notes as well. Okay, always remember that the address that is basically loaded into the memory address register is known as physical address. Okay, and users cannot access physical address directly. Okay, but they can calculate physical address PA using logical address. Okay, so the user program, right, whatever program we write basically generates the logical address only. Okay, and the user think that the program is running at the logical address only. Okay, but the program mainly needs the physical memory in order to complete its execution. Okay, so the set of physical addresses, okay, which are corresponding to those logical addresses are known as physical address space. Okay, so that is what the overall idea is over here. Okay, so that is why we talk about the idea of memory management unit. Okay, which is nothing but a hardware device that helps for the mapping of, I would say, from virtual address to physical address or logical address to physical address. So we have a MMU unit present which helps for this mapping, because when the user writes the program, we store things in, or the user thinks everything is going in the logical address, logically, right, they think, but actually everything is stored in the physical address. So how does this mapping of logical to physical address basically works is through memory management unit. Okay, in the memory management unit, the value, okay, in the relocation register is added to every address generated by the user. Okay, now for understanding this point, we have to take an example over here. Okay, now over here, what you will see is the base register, okay, is basically known as relocation register. Okay, now here the relocation register is a special register, okay, present inside the CPU itself, which is used to map the logical address used by a program to the physical address, which is actually in the system's main memory. Okay, and the value in the relocation register is added to every logical address, right, that is generated by the user process at the time when we try to convert it into physical address. So if the logical address is 346, you have to add the value of relocation register 14,000 over here and then convert it into physical address. So using a simple relocation register, you can do this. Okay, relocation register also known as base registers. So here the value in the base register is 14,000, right? So if a user is giving 346 as a logical address, it is going to be mapped to 14,346. Why? Because we've simply added 14,000, the value of relocation register, to it. Always remember, as a user, you are just going to deal with logical addresses only. The memory management unit, right, basically converts the logical address to the physical address. Okay, and the final location of the memory address, right, is basically not determined until that reference is made. Okay, so this is what the idea is whenever we talk about the concept of logical address space and physical address space. Okay, here the important point over here would be about relocation registers that you have to understand. Let me write a little bit about relocation registers as well, right, so that you have again something to refer as well. So first, we'll talk about relocation register. Okay, so the relocation register okay, is basically a special register which is present in the CPU, okay, and it is used to map the logical address which is being used by a program to physical address to the system's main memory. Okay, and the value you have in the relocation register, now if you read the point, right, the value in the relocation register is added to every address that is generated by the user process at the time, okay, it is sent to the physical memory. Okay, so that's what the overall idea is. Now what we'll do is we'll quickly summarize the difference between both of them as well. Here, let's say I keep the logical address and here we have the physical address. These are more or less the terminologies that we are introducing right now because they will be used later as well. Okay, so first of all, logical address is what users can access. Okay, users cannot access. Here I'll just write cannot access. Okay, second thing what we have over here is the logical address. This is generated by the CPU. Okay, and here the physical address is basically located. This is the actual address which we have in the memory unit. Okay, the user can access the physical address with the help of logical address. Like I told you, right? Using a relocation register base register value, you can access the physical address using logical address. Okay, on the other hand, right, we can say that the physical address can be accessed by a user indirectly. Okay, the set of all the logical address that are generated by a program is known as logical address space, whereas the set of physical addresses corresponding to those logical addresses is known as physical address space. Okay, so here same thing is that the set of that are generated by a program is known as logical address space. And over here, set of physical addresses corresponding to logical addresses is known as physical address space. Okay, so that's what pretty much the overall idea is over here. Okay, so I hope this is clear to everyone as well. And now if you will go through all these points again, you will actually understand what we were talking about. Okay. All right. So the next thing that we are going to talk about is the concept of static and dynamic linking. Okay. So what happens is, to actually perform a linking task, okay, a linker is required. Okay. Now we'll talk about what a linking task is. So basically a linker is a program that takes one or more object files which are generated by the compiler and combines them into a single executable file. Okay. Think of it this way. There are two types of linking that exist. First, let's talk about static linking. Okay. Now, when we click on a .exe file, okay, of the program, right, and it starts running, right, all the necessary contents of the binary file has been loaded into the process's virtual address space. Virtual address space was logical address space. However, most programs also need to run a few functions, okay, from the system libraries, okay, and these library functions also needs to be loaded. Okay, so what happens is, here in static linking, the linker basically combines all the necessary program modules into a single executable program. Now, what you must have seen is when you were, using JavaScript, or even when you use like C++, Java as a language, you usually have a lot of program or like modules imported, right? For example, we were using Express, right? And you must have also used like body parser and a lot of modules, which is basically a set of code which anyone else has written and you need to incorporate it in your own program. Now, what happens is, whenever you will try to run your program, because you have all those dependencies, you want to make sure that all of those program modules are also there. So what the static linking does is, the linker present in static linking basically combines all the necessary program modules and binds it into a single executable program. Okay, so that at the runtime there is no dependency. Whatever you need has already been provided to you, has been picked up, has been taken from the dependency part and has been given to you as the dependency. Okay, some operating systems support only static linking, in which the system language libraries or the system libraries are treated like any other object module. Sometimes you must have seen that you are using some of the core modules also, some of the system libraries also. So in that case also, the operating system treats those system libraries also like any other object module, and it basically loads them and makes a single executable program, so that when you run it, there is no dependency at the run time, which is basically required. Okay, so that is what the idea of static linking is here. But when we talk about dynamic linking, the basic concept of dynamic linking is actually very similar to dynamic loading. Okay, so in dynamic linking, stub is basically included for each appropriate library reference. Okay, so what happens is every dynamically linked program contains a small statically linked function that is called when the program starts. Okay, and this static function maps the link library to the memory and runs the code that the function contains. Okay, so remember, a stub is a small piece of code, and when a stub is basically executed, it checks whether the needed routine is already in the memory or not. If not, the program loads the routine into the memory. Okay, so what it does is, in dynamic linking, if you have a program, it is also going to have dependencies. But what we do is we actually include stub. Stub is basically a small piece of code that links the library that you have, right, to the memory, right, where those libraries are basically present. And when you try to run the program, the first thing that gets executed is stub, right? And then when you're executing the program, the stub basically keeps on checking that, okay, here you need some program module, whether it is really present or not. If it is not present, it will load it into the memory. So at the runtime, you are actually taking care of the program modules required for your program. Whereas in static linking, before actually you run the program, you take care of the fact that every corresponding program modules are already there and they have been linked into and combined and bundled up into a single executable program. Okay, so that is what the concept of static and dynamic linking is. All right, next what we will do is we'll talk about the concept of swapping over here as well. Okay, so what happens is, here I told you that each and every program initially is present in the secondary memory. Okay, and whenever a program gets or starts getting executed, it is basically becoming a process when it has some CPU or some other resources basically allocated to it. All right, so what happens is, here, let's say you have a process and due to some interrupt, right, the termination of a process is basically happened. So it was executing, but now it is basically not allowed to execute. So all the resources which was allocated to it initially has been taken back. So this is a common scenario where a process can be temporarily taken out of the primary memory. So it was initially in the large disk, the secondary memory, but now it has been taken into the primary memory. But it may happen that temporarily we actually swap out processes out of the memory to the backing store, the large disk, right, the magnetic disk that we have. And then if in future the resources become available again, if no higher priority process comes in compared to the current process, that particular process can be brought back into memory again, and then its execution can be continued. So it's like, it's secondary memory, it's primary memory. You take a program, you put it into primary memory, you start executing it, or maybe you didn't execute it, somehow the priority of the process was very low, so you have to bring it back to the large disk or the backing store. So this kind of a phenomena, okay, where, right, you are swapping a process out of a memory, right, is known as swapping. So to tell it in very designated terms and definition terms, swapping is a memory management technique and is used to temporarily remove the inactive programs from the main memory of the computer system. Any process that needs to be executed must be in the memory for its execution, right? But sometimes those processes can be temporarily swapped out of the memory also to the backing store, and then we also bring them back again for their execution also, and to complete the execution from where it was left off. Okay. Swapping is done sometimes so that if it's a low priority process, it can go back and some other process gets the memory for their execution. Okay. So that is why that is how we talk about the concept of swapping. Okay. Now, due to swapping, right, swapping technique performance, right, what we basically say is, because there's a lot of swapping happening, processes are moving out of the memory, right, performance usually gets affected sometime. Okay. But it also helps in running multiple processes parallelly as well. Okay. Low priority processes, like I told you, sometimes may be swapped out with a higher priority process which is loaded and it gets executed. Okay, so that is how the concept of swapping works. So there is one thing which is roll out and roll in. Okay, so this is basically a variant, right? A way or another variation of this swapping policy that is used for priority based scheduling algorithms. So if you've not learned about priority based scheduling, I would recommend to watch those videos as well, wherein what we do is during the process scheduling, there is one of the process scheduling algorithms known as priority based scheduling, because there are a lot of processes in the main memory, all of them are trying to get executed, but if you follow a priority based technique, every process will have some priority assigned to it, and the processes with the higher priority will be allowed to execute first. That is known as priority based scheduling. So the idea over here is that if a higher priority process arrives and it wants to basically get serviced and executed, the memory management can actually swap out a low level priority process, okay, so that the high priority process can load and get executed. Okay, because here you know that for any process to execute, it has to be in the main memory, but currently the main memory is filled, right? But some higher priority process came in. So what do we do is we take a low priority process, we swap it out so that the higher priority process can come in. Okay, and when the higher priority process finishes, the lower priority process can again be swapped back in and continued if its execution was left off. This variant of swapping is known as roll out and roll in, where you are rolling in the process in the memory and you are rolling out some processes out of the memory. Okay. The major part of the swap time is the transfer time, correct? Because here you want to transfer the processes. So that's what it takes the major time when you have to apply the swapping technique. The total transfer time is directly proportional to the amount of memory that you are swapping. Okay. Basically how much time it will take, right? But will also depend on the part that how much are you really swapping. If you are swapping many processes, right, and it can take a lot of time. If you're swapping less processes, it can take less time. Okay. But understand also that swapping is one technique, but different operating system these days apply or have found of modified versions of swapping as well, which they apply in their system. But on a very basic level, right, this is how the swapping technique basically works. Here you can see a small example also, which basically helps you to understand this topic in great detail. Okay, so here what you can see is you have the main memory and always your operating system is residing over there. Okay, this is like a multi-processing environment with some I would say scheduling algorithm that is working in. Okay, so what happens is you have process P1, okay, and you have process P2. Okay, so what may happen over here is, let's say the process P1 was initially in memory, okay, but some higher priority process P2 basically came in, which wants to get executed first. So what do we do is we are swapping in primary memory, we are swapping in the I would say the process P2, and process P1 is basically swapped out of the memory based on the priority of the process. Okay, always remember that the swapping of processes by the memory management has to be fast enough. Okay, so that the processes can quickly come into memory, get executed, and then go back, and the process which was swapped can come back in. Okay, and with this we talked about the technique of rolling in and rolling out, where if you are doing it on the basis of priority, a low priority process basically goes back and a high priority process basically comes in. Okay, so whenever we talk about the advantages of swapping as a technique, Okay. Always remember that the swapping technique mainly helps the CPU, okay, to manage multiple processes within a single main memory, because swapping actually helps you to escalate the process or the idea of running multiple processes in parallel. Okay, so swapping is a very useful technique, and this technique is economical. It's not a very high overhead technique. It doesn't take a lot of overhead, and based on that, what advantages it actually provides is far more. Okay, and this technique can easily be applied to priority based scheduling in order to improve its performance. Okay, these are some of the advantages, right, that basically helps in swapping. Because swapping is there, so processes do not have to wait a very long time in order to actually get executed. Okay, so these are some of the points which you have to remember about swapping. We are going to discuss after this session also a lot of other techniques as well, which can get confusing a little bit. So we will have relevant different points also to understand the topic, but make sure the overall core idea is clear, because in memory management as a topic, a lot of ideas like this will come. So it's equally important that every one of us understand all of these ideas in detail. All right, thank you so much for taking a look at this video now, and in the next video we are going to start talking about memory allocation. Okay.